Good afternoon, everyone. I'm Yantao from the Hong Kong University of Science and Technology, and I'm currently a youth editorial board member of JBDE. And it's our great pleasure to welcome all of you to today's JBDE Frontier Forum. The forum actually is an important academic platform for our journal, aiming to bring together experts from around the world in the fields of built and environmental science to share their research achievements. So today we are really honored to have Professor Heng, who is also my PhD supervisor from the Hong Kong Polytechnic University as our distinguished speaker. So before Professor Heng's speech, please allow me to take a moment to briefly introduce the journal. So the Journal of Building Design and Environment, founded in 2023, is a gold open access journal. So it focuses on cutting-edge sustainable technologies such as intelligent construction, structural design, building energy, and so on, as listed on the slide. So to ensure academic quality, the journal implements a rigorous single-blind peer review procedure and publishes only 3 issues per year. And to support our researchers, the journal will not charge any article processing fees before 2029. So please chase this opportunity if you have wonderful research outcomes want to share with all of us. And our goal is to build an influential academic platform with a development target of achieving an impact factor of 7. And our journal also has an official WeChat account as shown on the slide, where we regularly share updates and academic activities. So we warmly invite all of you to follow and support JBDE, our journal. Next, I'm honored to introduce the distinguished editorial leadership team of JBDE. We have Honorary Editor-in-Chief Professor Jian Kang from UCL. He's a renowned expert in architectural acoustics. Our journal is led by 2 editors-in-chief, Professor Limao Zhang from Huazhong University of Science and Technology, and Professor Xiangyu Wang from East China Jiao Tong University. In addition, we have 9 associate editors listed here who contributed a lot to our journal. And in addition to ensure the highest academic standards, the journal has established an international editorial board. Currently, we have 35 scholars from 10 different countries and regions serving on the board, bringing diverse expertise and global perspectives to the journal. In addition to that, we also have established a dynamic young editorial board. So currently we have 47 early career scholars from universities across 7 countries now actively contributing to the journal's development, bring fresh academic energy and innovative ideas to JBDE. And to further promote global academic exchange, JBDE has launched 2 major series of academic activities this year. First is the Frontier Forum, which started in March, has already had 7 sessions. We have invited internationally renowned experts in the field of built environment, like Professor Vivian Tan from Western Sydney University, and also Professor Matt St. Maurice from the University of New South Wales. Secondly, to provide a platform for early and mid-career researchers, we also launched the Emerging Forum in October. The first session featured by Professor Chao Liu and Professor Zhenhua Duan, specialists in concrete structure research. And through these 2 forum series, we aim to offer scholars an open and active space for academic exchange. And in addition to all of these forums, JBDE has launched the Voices of Scholars interview series this year. So here we will invite emerging and dynamic researchers from various fields to share their insights and experiences. So far, we have featured 8 scholars focusing on topics like resilience buildings, net zero energy buildings, and the data-driven innovations in building technology. So we warmly welcome scholars from all fields to participate in our academic activities. Okay. So thank you much. Thank you all of your attention to the journal introduction. So now we will soon start our seminar today. So please pay attention that the seminar will follow by a free discussion. So in case you have any questions, please feel free to share your questions in the chat box. And if you want to speak after the seminar, kindly raise your hand and wait for the moderator to invite you. And also we kindly ask all participants to speak in English during the discussion, and please respect all viewpoints and avoid interrupting others. All right. So I will try to manage the time and follow up the discussion and to ensure a smooth and inclusive exchange. Okay, so finally, with no more delay, let's move on to the seminar part. So we are very pleased to introduce this keynote speaker, Professor Heng. So Professor Heng is a chair professor of construction informatics at the Hong Kong Polytechnic University, and his research focuses on digital construction, smart construction, ergonomics, and robotics. I believe like all of you have already heard of Professor Heng's research, so I don't want to waste too much time here. So today he will present his talk titled "Landlink for Smart Construction Safety Management." So now, please join me in welcoming Professor Heng. So, Professor Lee, it's now your time. So, I will stop sharing. Please feel free to share your screen.
Thank you so much, Yantao, for your very clear introduction of the journal and myself. And I wish the journal will soon become a leading journal in our field. Um, Today, I'm very pleased to share some of the research outcome that I have, produced recently. As Yantao introduced, the topic is about land-link technology. Um, uh, Before that, I just want to give you a very, snapshot of my background. I initially started my work in the area of digital modeling. Those time it's called the virtual prototyping, and later I moved to doing digital and smart systems for construction safety management. During my research and practice, I actually realized in construction there are many actually challenges. But if you want to build any digital or smart system, uh, one challenge, if that is not the most difficult challenge, is to provide a full connectivity, to provide a good network, because any system, any digital or smart system has at least three layers. The first layer is a data acquisition or data capture layer, using sensors or computer vision. And then all this data has to be transferred to a CPU, to a computer. This transmission can be done by, uh, you know, by uh, by cables or by wireless network. Because in construction, Using using optical cable is almost impossible because you can see from these diagrams that the construction can be very, very complicated because it's changing all the time. Also, it's because it's so dynamic. Using cable, using optical cable, um, it's it's very difficult to maintain because when you can imagine if a car or any vehicle go through these places will easily break and cut the cable. And also because the increasing use of these robotics systems, you know, any compute, any robot will increase the data transition volumes. So all these actually increased the difficult in providing a full connectivity. So, because of under this background, we have tried a lot of methods. Initially, we thought network is not a problem because we initially wanted to search a commercially available system such as mesh Wi-Fi or use 5G. For mesh Wi-Fi, the problem with it is the mesh Wi-Fi cannot cannot transfer for long distance. One key problem with mesh Wi-Fi is during this transmission or during this one hop, mesh Wi-Fi will lose about 50% of signal. So after three or four jumps or hops, mesh Wi-Fi will become useless. But for 5G, it also has a problem. But 5G is used for for not industrial use. For example, if you use 5G to watch videos, it's okay because the downloading speed is very, 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 very fast. but the uploading speed actually very slow. You probably experienced when you want to transfer a video or a very big PPT file to your friend. You will see this uploading speed is very slow because uh, 5G or even 6G is not actually designed for industry use. So, in summary, all these existing devices, including 5G and mesh Wi-Fi, cannot provide the connectivity that we needed in the construction, in smart construction system. These are the bottlenecks we needed to overcome. So under this background, the research team worked with me actually developed a new technology called Landlink. The Landlink actually overcome all these problems I just described. Now, the first problem is the Lightning it has this equal division of upload and download speed. So you can see that in our system, the first generation, the upload speed is 400 megabytes. This is about 4 times faster than 5G uploading speed. And also, because we have actually overcome the problem with mesh Wi-Fi, in this wireless communication of Landlink, the signal loss is reduced from 50% to 2%. That means our technology can jump about 30 times, and because each jump can span about 2 kilometers. So as a result, we can provide point-to-point distance of 60 kilometers. Okay, so this system, with this the technology, we can almost provide a very good connectivity to construction scenarios. This is the technology that we actually developed. In order to promote the use of this technology, we also have registered an international patent. This patent allows us to deploy it in almost any country worldwide. So this is the technology that we have at the moment. If we do a very simple comparison with between our technology and 5G and 6G, we can see a very obvious difference. First, our technology is very flexible. It's portable. It can be actually installed in a very short period of time. For example, using 5G, 6G, if there's no station, then you have to spend about 3 months to build a tower and to establish all the stations. But in our case, we need maximum 7 days. Most time we only need a few hours to provide the network. And also our technology consumes much less power because we use 8 watts to support the the whole day operation of the network. And also because our system actually has gone through a thorough test to ensure its network safety and the connectivity. So our system is much more stable. Also, the latency is much lower. In our system, our latency is less than 1 milliseconds, but 5G, 6G is between about 30 to 50 milliseconds. This latency is very important because in many scenarios or many applications, if the latency is very high, that will affect the remote operation of the machines. I will mention some cases later on to demonstrate the effectiveness of our technology. I show you some cases that we have actually done in Hong Kong and elsewhere. The largest application in Hong Kong is Hong Kong um, uh, Airport, the third runway T2C project. This project actually is a waiting hall. If next time if T2C is opened, you probably will notice that the whole wireless network is actually is developed based on network Landlink technology. This building has the shape is like Y, you know. It has one layer underground and the three floors above ground, and then the whole structure, including underground layer and the three layers above ground, are all actually supported by our Landlink technology. The reason for airport authority to adopt this technology is because firstly, our technology actually is independent from public network. So even if there's a fire, we know in Hong Kong there was a recent fire tragedy, but in a fire situation, even if some network are disabled, um, our technology has a self-rehealing or self recovering capacity. That means the technology can still provide a partial network. So it's very resilient. This is a very strong reason for Hong Kong Airport to adopt our technology rather than Hong Kong telecommunication or China mobiles, because in their technology, if one station is destroyed, the whole system will be disabled. This is one case. Um, uh, Based on the technology, we have developed uh, 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 a total decision-making systems for many industries. The basic idea is, uh, I said it earlier, in the front layer, we use different type of sensors. You can see from here, the system can connect with gas detector, can connect with a smart watch, smart helmet, computer vision, and so on. Many of these devices actually are developed by my own team. We have now commercialized the technology. Um, and then the middle layer is the data transmission or network technology. It's based on our Landlink uh, technology. Then the data will be transmitted to the central processing unit, where the decision about productivity, safety, and so on, there can be made, and then all the decision then can be feedback to support the project management. That is the basic idea of smart system in construction. Um, uh, we also have attracted some publicities in Hong Kong. The Development Bureau, this is actually the most important authority in Hong Kong overseeing the construction industry, has actually nominated us as the very important innovation in Hong Kong. Okay, I just gone through some of the basics. Some of you probably have heard the 4S system. This system is advocated by Hong Kong Development Bureau. If you don't know what it is, it basically has 10 items. Um, the number one item is a centralized platform. It's actually is a portal for different management purpose. but 2 to 9, item 2 to number item I, are solutions to overcome fatalities in the construction industry because number 2 to number 9 are um, are identified as major contributors of fatalities, fatal accidents in Hong Kong. For example, um, uh, if you look at number 9, is confined space monitoring system because in the past many workers were killed in confined space because of harmful air or poison air quality that killed the workers. So the purpose of this confined space monitoring system is to provide a real-time air quality monitoring sensor. So when the air quality is changed, then the sensor will start to alarm and the worker can escape. That's the basic idea. I will show you some of the snapshot of the system that demonstrate how we actually provide solutions for this number 2 to number 9 items. And our technology are now all being approved by CIC. So if you use the workers, the Hong Kong companies use our technology, they will get a lot of subsidies to use technology. Uh, for example, that's how we install our devices. What you see here is in Hong Kong, many confined space are locked by this electrical locker. If the worker have to enter this area, they have to get a permit from system, and then the site agent will issue a permit to certain person, so to allow them to go into the area. So the once the permit is set, then all the message was sent to the the smartwatch that the worker is wearing, or the ID that the worker is using. So using the smartwatch or the worker's ID, he can actually unlock this electrical lock and enter this area to work. And once he finished, or before he finished work, his movement will be monitored by this smartwatch, and the central platform will see his movement, and sometimes using the watch you can even predict his gesture, his status, and so on. Once he leave, and then all the information is stored to keep and calculate how much work has been done by this worker. Um, uh, this is another snapshot to indicate this how this digitized permit to work system is actually workflow, because you are not working in the industry. I just quickly go through them. Um, this is a device to monitor, because this lock can only the battery of lock can only last about 2 days. So we have system to to automatically charge the lock, and also once the charger it needs to be recharged, then we actually can um, uh, display this request in the system, and someone will come and to replace the charger as well. So the whole system is interconnected by our NetLink technology. Um, this is a snapshot of a tower crane management system in Hong Kong. The government requests that under this hoisting area of 7 meter by 7 meter zoom, we have to make sure no workers are standing within this danger zone. So we developed an auto zoom system, and even if the the hoisting goods is moving up and down, we can make sure the zoom area is always 7. Um, and also we can um, we can monitor the cable the cable of the tower crane to make sure the cable is always strong, will not break. Because in Hong Kong, there are some in the past a few factory accident was caused by the sudden break of this cable. So again, we need to monitor the you know the wearing and the conditions of the cable to make sure there's no danger of breaking. This is another case. All these are a real time and then needs a very strong network. And in Hong Kong, the government requests that each worker has to wear a smartwatch. The smartwatch, using it has two problems. One problem is the normal watch can only last 1 day. Then the battery can only last 1 day. If it can only last 1 day, then the management of recharge it is a very difficult task. So our team modified this watch so that we actually disabled about 70 to 80% of functions, so that as a result, this watch can last now can last 1 week. Um, and and also we have linked the SOS alerting system with the worker. And sometimes sometimes the alerting system can generate a lot of false alarms. For example, if the worker is sitting there to eat lunch or sitting there to rest, and then the automatic alarm will send to the worker. So to reduce the load of management, so we for many these uncertain alarm, we will actually send this message to the workers themselves. If the worker sees a, a message like this on the watch, he can actually click cross to disregard this. If the worker doesn't respond, then we'll assume this is actually a real danger, and someone will come to rescue the worker. That's how we actually exercise this real-time monitoring system on site. For confined space, in the past, nobody could do real-time monitoring because there's no network. Okay, with our technology, we can put a device at the entrance of this confined space, and then this device network will actually cover 2 kilometers. For this tunnel, you put a NetLink device at the tunnel, then the whole tunnel will have a full coverage, connectivity. Then with that, we can monitor the movement and the air quality within that tunnel. So actually, our team first time realized, real-time confined space monitoring. This is how we implemented. What you see here is first the worker put a device at the entrance, then the worker might wear a gas detector or body camera to go into the tunnel to work. Then we actually can real-time monitor everything. Okay, this is one of the cases we have done. This is actually a continuation of a previous case. We also have done different cases in addition to 4S. For example, we changed the normal computer video camera so that we integrate the normal camera with infrared camera so that during the daytime it can monitor workers' movement. At night, it will actually become infrared camera to detect if there's a fire alarm. And if there's fire, we can actually use it for fire safety management. And also, the system can link with smoke detectors, and all this information again can be transferred to platform. So the advantage with our system is even if there's a fire, as I said, because we don't use cables, um, the network cannot be fully destroyed at the same time. Even if some stations are destroyed, and the whole system will provide a partial coverage. This is our advantage. So the system can be functional even during a fire situation. We also have a project for structural health monitoring because in Hong Kong, this a new stadium in Yunnan, they use the S690 high strength steel structure. Then we propose to develop a real-time monitoring system to monitor the stress and the strain and the movement of the steel structure. This is still undergoing. We have done the 4S, and now we are moving to the structure health monitoring area. We also have tried to connect the vibration detector with the network. So this is another applications. For some areas, especially for deep excavation, we have to monitor the inclinations. This device is called the inclinometer to make sure the excavation is done, horizontally, vertically, perfectly vertical. This is called the inclinometer. We also monitor the water levels, so to make sure there's no flood. We also do noise monitoring, and also we are trying to develop a technology to actually neutralize noise. So all these requests are from the industry. So the team, if they want to survive, they have to actually all the time to respond to the industry needs to provide the solutions. There's an also a very interesting case where the network is used for remote cleaning robots, because for situation like a tunnel, this obviously is no good coverage. So we put the network technology on the top of the tunnel, and then send this uh, dredging robots to do the cleaning. This is a tunnel project where the TPM machine go forward from left to right. Then at the end of the TPM, we put a NetLink technology to make sure all the information is actually transferred and back to the central monitoring center above the ground. We Because the team is actually independent startup company. The team is trying to promote or trying to enter different areas, including smart cities, industrial automation, smart health safety, and agricultural, and so on, because they want to become self-sustained commercially. Okay. We have operated almost 18 months now. So far, we have done more than actually 40 projects many in Hong Kong, some in mainland China, and a little bit overseas. So I'll show you some real projects just to give you a feeling of how much we have done. This is a project. I said the first time that we detect the air quality problem just after the rain, when the worker get into the tunnel project, and then they detected the air quality changed and become poisonous, and they have to escape. And so this is actually the first time in history a case like this is detected. Without this system, very possible some works will die. Okay, and this is the confined space monitoring system I mentioned earlier. The worker use their smart watch to open a gate and to enter a confined space to work. This is a permit to work underground system. We also have done some projects in remote areas. But in Hong Kong, the recycling is mainly dependent on landfill. So in the landfill, there's no signal because they're most like the remote areas. So the Environmental Protection Authority invited us to set up a monitoring system to make sure the area is monitored, and then the trucks is done their done the job carefully, and then they actually plan very soon there will be unmanned truck dumping system coming into the landfill the system very soon. This is a high-rise building. We use the technology to provide full connectivity for the multiple floors to monitor the health and safety, and then the construction progress of this project. This is the airport T2C project I mentioned earlier. This is the largest project we have done so far. Okay, this is the layout. I said it's a three layers above ground, one layer underground. So you can see the layout. This is another landfill project. The biggest projects in Hong Kong so far used our technology for network. Shen Honggai is one developer in Hong Kong. They own a telecommunication company called SmartTone. But even SmartTone cannot solve a problem. The problem is demonstrated at the left diagram, where the side office shown the blue dots is away from a site. It's about 450 kilometers. At this side office, they have a very weak 5G signals, but at the side there's no signal at all. So our job is send these 5G signal, 5G or 4G signals across 450 meters distance to the site so that they can communicate to each other. So what we have done is we put one Landlink station at the side office, another on the side. You can see on the this a power line post on top of it. So the distance is 450, and so we after these two stations are installed, the site can talk to the side office with no problem. We also have done some projects in mainland China. This is a highway project connecting Sichuan with Tibet. Um, it's about 400 kilometers. But the problem is there's no signal, no coverage at all, no network. So they use our network. You can see this person. He actually has been working on the project for 2 years. He couldn't use his smartphone because there was no network at all. So with our network, he was so happy. He tested our system. He was riding a little motorbike and then using his phone. You can see uh, the testing result is very good. You can see at the top of it, um, the the uh, the network speed is very stable and very fast. So we are now slowly but steadily moving into different industries. Another industry we entered is uh, port industry. We worked with about 8 ports in mainland China. The reason we choose port is because of the port industry is financially very healthy. They have very strong cash flow, and also for ports, they want to do a lot of um, activity to introduce more smart digital devices. For example, they use uh, uh, o- um, uh, automatic dock, robotic dock for monitoring for for this port supervision. They use remote um, tow crane control. All these all these applications needs a very strong, fast network. Um, uh, the port industry searched many suppliers, many technologies, including Huawei, including China Mobile. Um, at the end, they decided to use our technology because our technology is cheaper, faster than Huawei and China Mobile. So you can see this is a case where um, the tau crane is very much like our tau crane. In their industry, they call it 轮胎吊. The operator is actually sitting about 7 to 10 kilometers away in the central control room. Using our network, they can control all the operations within more than you can see using 12 cameras and different sensors to monitor the whole operation. But the very important um, uh, result is that using our technology, the delay, the latency is only less than 10 milliseconds. You can't feel the delay. It's almost instant. But using 5G, the delay will be about 100 milliseconds. So this is one reason they use our technology. We are much faster than 5G. Okay. Um, I'm I'm probably running a little bit fast. I I the reason I volunteer myself to come to deliver this talk first, doing IT or doing uh, smart construction research um, is very interesting because it includes many aspects, many areas, but to implement this technology on construction projects is actually very difficult. I have tried many different things in the past. Um, uh, 27 years ago, I started BRM applications, and also I've tried many other things. Many of them have failed, but seem to me, seem to me, if you could find a real pain point, real real challenge, and provide a innovative solution, and if you can improve to the industry that your solution is better, is cheaper, is faster, then there is a chance for the industry to accept us. So it seems to me Landlink is is getting there, is becoming a part of the industry, accepting the industry, at least in Hong Kong, is accepting us to become part of the smart construction solution now. University professors or university researchers sometimes can do some real uh, applications. So if you if you are an earlier career researcher, maybe it's not um, your task to develop products to do so many implementation of your new product. But if you get into my age, and my age is almost at the end of my career. I'm about you know going to retire, so I want to leave something in the industry to firstly to extend my working life, and also just to demonstrate that sometimes research can generate tangible and useful technology. Um, we are not only talkers, sometimes we can do good things as well. This is the reason I choose this topic to show you. But anyway, I'm not sure I have conveyed my message clearly, but at least I've tried. So, Yantao, I give my time back to you now. If anyone have any questions, or you have any interest in what I've presented, I'm very happy to talk to you now or later or through email. So. Once again, thank you, the journal for inviting me. I hope all the best with you and with the journal. Thank you so much.
Yeah, thank you, Professor Lee, for a really wonderful presentation. I think it's really, at least for me, it's really eye-opening to see so much research outcomes can be really grounded in real applications. We all know that it's even for one product, it can be really difficult, but you present a lot. Yeah. So, yeah, any questions? So Q&A time. Any questions from the audience? Yeah, we have received one from the live channel. So the question is, what are the future research and development directions or expansions of application fields for the Landlink platform?
Yeah, Yantao and the person who asked questions, we do not have a bigger plan. The 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 initial our wish list include many things, but most importantly, we want to survive in the market. um, this team of actually is a company. The company name is called the Smart Construction Laboratory Limited, and is stationed in Science Park in Shating. We have we have about altogether, including Hong Kong and different parts of China, we have 33 workers. Um, all of them are paid by by the earnings from all this operation. So most importantly, we want to survive. We want to make sure we still will get more continuous income. The other important thing is we want to make sure our technology is always a little bit better than uh, than we can't say competitor. Very luckily, so far we don't have a very obvious competitor. Um, and second wish list is um, we can see uh, robots are coming into the industry. Very soon, repetitive jobs will be replaced by uh, humanoid robots. I'm very certain this will happen. But each robot has at least 50G traffic, data traffic. That again increase the bandwidth of the communication. Um, so, so that again reinforce the needs of network. We want to build a faster, better communication highway for this new era, that is the robotic era. Um, I think in Hong Kong, it's very hard to do manufacturing task. To build the robots is almost impossible. So I think to prepare for our future, uh, uh, one aspect is to build this highway, the network. Another aspect is to build a better interface between human and robots, so that they can understand and learn from each other. So this is my interest. I want to do this both, hopefully, and work with you, with Yantao. Um, and this might be a breakthrough point because Hong Kong really has a problem because we have a shortage of uh, uh, labors and also I think existing robotic devices may not be uh, not useful in the Hong Kong situation. Hong Kong is very small and the site are very messy, and then so humanoid computer robots may be more suitable. Okay, so we, myself and the team are actually going from another end to enter this new era. We will find a partner, maybe Yusu or Musk's Optimus.
Mhm.
So that we can say, hey, we work with you, provide network, we train your robots to become construction worker. This is our basic thinking. Okay.
Yeah. I'm
Yeah.
also quite interested in this idea and hope one day can have the opportunity to collaborate with you to really make
Yeah, yes,
humanoid
Yanta, we should
happy,
do.
like working on sites. Yeah.
Thank you. Yeah.
Yeah. Yeah, we also have another question. It's about how do you envision Landlink supporting future construction industry IoT frameworks? And is there a roadmap for integration with digital twin and the BIM platforms?
Okay. Digital twin obviously is now becoming accepted concept. People all using digital to the life cycle management. Between the digital, I think again, digital twin is the a digital version and the physical world, and they have to somehow link, and then they have to somehow uh, to coexist. But between the physical version and the virtual or digital version, we need a network. This is also, I think, why we build the technology of Landlink. So I'm quite certain that the Landlink has its wide usage in many
Mhm.
areas. Um, but slowly, people now notice us. We get queries now. We get phone calls almost every day from different areas. From even like Australia,
Wow.
from Middle East. Hopefully, the situation will become better. Where I have less worry.
Wow. Sounds great. Yeah, I
Yeah.
totally agree that Landlink should be served as the foundation for maybe almost all of the digital twin platforms because it has like huge demands regarding like data transformation, and Landlink provides such service. Yeah. Yeah. So do we have any questions from audience? Or the audience in Zoom can directly speak up if you have any questions. Okay, so even though I think it's almost the time, so thank you, Professor Heng, for your time and for a very nice sharing. And yeah, we hope every like success in your future in the development of Landlink. Yeah, and thank you so much for every audience for your time enjoying the seminar, and wishing you all of a wonderful week and also happy Christmas. Yeah, thank you so much.
Thank you so much. Thank you.
Yeah.
Thank you.